Okay, next, let's go ahead and get some models up here. So let's go ahead and do some imports. Let us from sklearn.ensemble go ahead and import random forest classifier. And is gradient boosting in here too? Yeah, gradient boosting classifier. Got to export XGBoost separately, so that's from XGBoost import XGBoost classifier. XGB classifier. There it is. And then let's not do cross validation so that I don't want to. It's kind of interesting, right? So we're using time, okay? So we're going to time things, but I don't want to like just spend extra time waiting like for cross validation. So we'll just build the model straight out. These are classifiers, and one way you can do it to get the scoring metric is from sklearn.metrics. We can import, I guess, the accuracy score. Let's see. Yeah, accuracy score. And then also we can do train test split. Wait, that's not a metric, sorry. So where's that? From sklearn dot, oh my goodness, it's been some time since I've done it. Where does it live? If you're ever wondering, by the way, you forget like something, look, because they have different libraries, right? So I know it's train test split, and maybe like I'm, can't remember where it is. Well, you could certainly just look it up. You can type in train test split, right? And so when you do that, you're going to get, there it is, sklearn.model selection. So, you typically get it right out of the bat, okay? You can see it's sklearn.model selection train test split. That means it's in the model selection library, okay? So the way you would import that then would be from sklearn.model selection, import train test split. Okay, so that should take care of the imports. Say prepare imports for machine learning. All right, and then next thing we want to do is use the train test split to split the data. Now, I do want to be clear. So you may have noticed sometimes we're splitting the data, sometimes we aren't. What's the deal with that? Well, generally speaking, you always want to split your data. And, I've mentioned before about that I would talk later about kind of why. Well, first let's split it. So how do we, well, we have to declare an X and a Y first, okay? So first split data into X and Y, right? And if you double check, right, you don't just want to assume, you want to check your data. So this data, it's all numerical. This is a cleaned data set. And way back here, the last column is the column that we want, the target column. Okay, so we got to do that. So standard X equals df dot iloc, all rows, and all columns except for the last column. And y equals df dot iloc, all rows, and just the last column. Okay. Now we want to split into training and test set. Okay, so that's X train, X test, Y train, Y test equals train test split. And so when you see, by the way, that right there, you have there are 4 numbers. That means it's like a 4 tuple, meaning it gives you, basically train test split gives you 4 outputs. And so you choose the 4 variables that you want to call them. This is the correct ordering. Okay, so let's run those. Okay, things look good so far. And the next thing we want to do is actually, let's just build a model, right? Let's start with the XGB classifier. So I'm pausing because like I recall that there may have been an issue with the naming of the columns that the XGB classifier doesn't like for some reason, like because of the greater than sign. But let's just check it. Oh man. And by the way, that's very common. Like sometimes when you're learning, we're presenting you with code that's all like neat and tidy. And it's common that like things don't go as expected and that you have to figure out why. So let's see. Just something going off in my mind there. Could be wrong. So what first model, right? So I want to define model. I'll go ahead and write out the code. Initialize. See, because we're going to repeat these steps, right? And we're probably going to write a function to do it. Okay, so initialize model. So model equals, we'll just start with XGBoost, XGB classifier, fit model on data. Okay, that's the next step. That would be model.fit. So I'm fitting it on the X train and Y train. Okay, now here's the deal. Okay, we're just running like a test for timing, really. And so we're going to score it on the test set. Okay, but even if you were doing cross-validation, you would actually want to do cross-validation on the training set. Because the reason why is that in a normal situation, you're actually going to want to make adjustments, fine-tune your model, and you're making those adjustments by comparing scores, say using cross-validation, okay? But when it's all said and done, when you have your final model, then you want to test on data it's never actually seen before. And that would be your X test, Y test. So it is good practice to always do this. Okay, next, and we'll get into that toward the end lectures too, on like finalizing a model. We just want to score it, right? Score data on test set. And then we can get that straight from the accuracy score X, Y. It's really 3 steps. I feel like I'm leaving something out here. Okay, let's see what happens. Run the code. It's fitting it. Oh, I didn't time it, so that's, yeah, I got an error. Yeah, I can't handle a mix. By the way, I didn't want X and Y. I wanted X. It shouldn't matter. X test and Y test. Oh, it's what I'm missing. I'm sorry. That's not how you actually do it. I am missing something. You want to see, you can't compare like X to Y. Okay. So what you want to do is you want to compare Y to the predictions of the model. So get predictions from model, model.predict. So the input then is the X. You're basically making a prediction on the training set. See, what you do here is you fit the model, okay? So it comes up with its own parameters, and then you basically put that, like here's the model, okay? You want to get all the predictions. What are the predictions? And I'm sorry, it's not train, right? We want to get the predictions of X test, and then we compare those to Y test. Okay. I forget which one is supposed to go first. It doesn't matter for accuracy, Y pred, but it will matter for some of the others. Okay, so let's try that. And you can see it takes a little time to run, right? Recall that an XGBoost classifier is building 100 models. Okay, so we didn't have an issue with the labeling. It did actually work with 86% accuracy. And so the only other piece now is to include the timing with it, right? So if we go back up to the timing code, I think I'll go ahead and include the import because I really want to have it all together and it works. Okay, so I'll chunk my timing code together and then my end code. Okay, so go ahead and copy it in. Okay, so basically I can do the same thing. Note that I'm not using any random states here. So, you know, I don't know that that's going to make much of a difference for a timer. You could expect that the timer should be different, you know, for different people. So I got 5 seconds, okay, 5.1 seconds. Okay, so the idea now is that I would copy this code and do it on the other models. However, copying code is not the way to go. Typically what you want to do is you want to write a function to do it. Okay, so that's what we're going to do. We're going to turn all this into a function, right? So what we're doing is we're going to write function that delivers time and score of model. Note that I only printed out the time here. So really, I want to print out the accuracy score. Okay. All right. Okay, so let's call it something, DEF. Time score model maybe. Right, and then what are the inputs? The inputs are going to be the model. And, I think we can just leave it for that for now, right? Because everything else is actually going to be the same, right? We're just running a comparison for models. But, we want to get the score too, right? Because that's meaningful. And then I just pasted in what I had. Now, if you ever get the situation and like you want to tab everything, you can just highlight everything. Oh, sorry, sometimes the cursor runs out. And press tab. And then, so the model, see, would be defined here as like XGB classifier. And so if I just say model equals model, right, now it should actually work. I think that's all we need, right? Because model's defined throughout. So let's try it. And now it says note time score model. And go ahead and put in the XGB classifier. Okay, and let's see what we get. Okay, so we get an accuracy of about 86% and took about 5.2 seconds. Okay, solid. Let's check now random forest for comparison. So note that a random forest also by default runs 100, like it's built from 100 decision trees. So these are like comparable bases of comparisons. And you can see, interestingly, the random forest here is actually faster, only slightly less worse. And the next thing we want to do is check the gradient boosting classifier, which is like the same style of model. And there is a difference so let's just try this one. What I was going to say is it's not fair to do it like with one decision tree, right? Because clearly that's going to be faster. So you can see gradient boosting and XGBoost perform about the exact same here. And the accuracies are also all pretty comparable for these three cases. So based on this, you might say, hey, like random forest maybe has a slight advantage, but it's also like gradient boosting is a different algorithm than random forest. And we could just run them another time. You could run them multiple times and even write a function to get their averages, right? And you can see it's going to be comparable each time, most likely. And it could be like slightly different, due to the randomization. And from this, you might think, yeah, like I don't see the advantage, okay? And so here's what we're going to do next. Look, we're in a world of really big data. 30,000 rows is not big data. So I'm going to access a bigger data set, and then we're going to do the comparisons again and see what we get. With one caveat, I'm not actually sure how the random forest will do, because note that it is faster, but like a random forest in effect, like there's kind of, is there more repetition? I mean, when I say that, I mean like within the code, because it's building 100 decision trees, but each decision tree is built based on the original data. When you get to gradient boosting, what XGBoost and the gradient boosting classifier are, each model is built on the errors of the previous one. So it has to wait, okay, for the previous model to finish. Do you see that? Because if you're building like the 17th tree and you say, well, I've got to like wait for the 16th tree to know the air to build it on. Whereas with the random forest, you can say, no, wait a minute. I'm going to build 100 trees here, but I already have everything I need at the beginning. So if I can use parallel processing to build like 20 trees at once, that's what I'm going to do, is build 20 trees at once. And so that's why I believe you see an edge in the random forest. It's not because of a superior speed thing that's like, I mean, it is, I guess, by construction of the random forest by its nature compared to XGBoost. And we'll see if that holds in bigger data. I think importantly too, we want to see if the XGBoost classifier does actually outperform, as it's supposed to, I can tell you, and the gradient boosting classifier.